dedicated to developing innovative solutions to expand access to adaptive sports. Our project began with a design challenge presented by the Disabled American Veterans, or DAV, who tasked us with creating adaptive sports equipment to help veterans participate more fully in recreational activities. The National Disabled Veterans Golf Clinic not only provides opportunities for physical activity, but promotes confidence by helping veterans rediscover their capabilities through recreational sports. However, participation often hinges on having specialized equipment tailored to different needs, and this is where our project makes a difference. During our fall semester, we had the opportunity to attend the clinic in Riverside, Iowa. While there, we observed a range of adaptive sports, including rock climbing, kayaking, cycling, and traditional golf. Many of these activities had well-established adaptive equipment available. However, we noticed that disc golf, despite its popularity, lacked the same level of innovation for players with disabilities. This highlighted a unique opportunity for meaningful impact, leading us to select disc golf as a primary focus for our project. Based on our observations and interviews with participants, we identified two major areas of need: supporting players with motor impairments and players with visual impairments. As a result, our team split into two subgroups to design separate but complementary solutions. For the motor impairment team, we noticed that many veterans who use wheelchairs face significant challenges with throwing discs. Limited torso rotation, reduced trunk mobility, and varying levels of strength made it difficult for them to generate the power and control needed for competitive play. Existing disc launchers on the market typically require substantial upper body mobility, effectively excluding players with disabilities like partial quadriplegia.
From this, our motor impairment team developed the following need statement. Disabled veterans with partial quadriplegia need a way to play disc golf with greater functionality and independence. While disc golf is widely accessible due to minimal equipment requirements, there are currently very few adaptive devices available. Our design process included evaluating various prototypes inspired by adaptive crossbows, which are often used by individuals with similar mobility challenges. These concepts ultimately led to our final device. In our final design, the user winds a reel mechanism that uses internal gearing to assist in pulling back elastic bands. Once the elastic is secured, the user can remove the hook and fire the device using the trigger.
Disc launching proved to be consistent, reaching up to 20 feet with standard discs and nearly 100 feet when using smaller lightweight discs. On average, setup time was reduced to approximately 1 minute per launch, allowing users to play with minimal interruption. User testing was conducted with 5 veterans with varying degrees of paralysis. Based on their feedback, the design received user-approved validation for ease of use.
Participants explained that they need improved grips and suggested a motorized reel to reduce the physical strain and time required to reload.
They said that mounting the launcher directly onto the wheelchair was the most effective solution, as it simplified setup and significantly reduced the fatigue of holding the equipment.
Switching to our visual impairment team, at the clinic we observed that veterans with limited or no vision had difficulty locating both the target and their discs, which reduced their enjoyment of the game. Although there are commercial beeping locators available, we learned from Patrick and his team that many veterans experience tinnitus. The high-pitched beeping from these devices can trigger or worsen their symptoms, making the products ineffective or even harmful. Further, solutions like neon-colored golf balls do not encompass veterans that are fully visually impaired. With this in mind, the visual impairment team developed the following need statement. Disabled veterans with visual impairments need a way to play disc golf with greater independence. While the sport is accessible and inexpensive, very few adaptive devices exist to support players with low or no vision. In order to give players more independence, we iterated through various ideas that would help with adjusting the player towards the goal or disc, eventually landing on an armband worn on the non-dominant forearm that calculates and communicates the distance and angle the user is from their target. The armband provides haptic feedback on the angle by vibrating the left or right motor to indicate which direction the user should rotate in. For distance, the armband provides auditory feedback through a speaker, which verbally communicates the distance in feet to the target. The target in this case is the goal, which is easily equipped with electronics that will send out a signal to the armband and make noise when the user is nearby through the speaker. This is the basket. The user sweeps their arm in a circle to find their target, rotating their arm left when the left motor buzzes and right when the right motor buzzes. Once the arm is pointing towards the target, both motors vibrate together. The user can then turn off the haptic and auditory feedback and begin their throw. An additional toggle switch also lets them choose whether they're tracking the disc or the goal. Based on user feedback, we also made the armband easier to wear by adding adjustable Velcro straps and magnetic modules that snap on after the band is secured. We truly hope both of these devices will help veterans play with greater independence and ultimately have more fun. We're grateful to the DAV, the Veterans Affairs Department, and our multidisciplinary engineering design course team for their support throughout this project. Most of all, we thank the veterans who shared their stories and insights to help shape these solutions. We're excited about the impact this work can have. Thank you for your time and attention.